Alright, we continue doing trigonometric ratios, and after a quick recap which trig functions in which case to use, so we continue doing problems itself. Okay, so if you are not sure which function to pick up from which ratio, depending on the case which side you're given, so make sure you watch that video. That was pretty short, and right now you are free to apply that tool to the following problem. Pause the video, try to do by your own, and let's get started doing together. Okay, so we've got A, B, C, and a isosceles triangle. So, and also we are given that AK equals KC. So those segments and the base part are equal. So that means BK is a middle bisector. So BK is a bisector. And what it means? Means according to the property for the isosceles triangle, it splits the bottom base AC on two equal parts. So and bisector becomes the height as well. So that's why it will arrange 90 degrees angle. So that's why we can conclude that BK is perpendicular to AC. If we apply that to the triangle ABK, we found out that ABK is right angled triangle. Right angled triangle. So what it means, we can apply trig ratios to it. Okay, so what we need to find angle X. So that's why we're given the opposite side opposed to the angle, which is 6 centimeters, and we're given the height in this case. So because we're given height, we definitely use either sine or cosine. Because of the opposite, we choose cos of the angle X. All right, so cos of the angle X is always opposite to height. And in this case, it's going to be 6 to 25. All right, so how to find angle itself? We just using calculator and input. We need to input inverse sine. That means, inverse cosine. So that means we're taking cos minus 1 of the fraction 6 over 25. Okay, so make sure your cos is less than 1, less or equal than 1, as in our case. And we've got angle X to be 66 degrees and let's say 11. So that's why to the nearest whole number is going to be X 76 degrees. Okay, let's move next. So we are given a rectangle with sides given below. Okay, 15, 25. Pause the video, try to do by your own. Okay, and we try to solve. In this case, I think we can solve in different ways. I'll show you the way one. So way one. Let's consider triangle let's say BCD. So consider triangle BCD. So it's definitely a right angle, okay? And the idea is pretty straightforward. Let's find this angle. Because let's say this is Y. This angle is going to be also Y. Why? Because BD and AC are diagonals, right? And due to the fact of symmetry, they will arrange the same angles. And by the way, they're also split up. So that's why triangle, let's say point O, triangle BOC is an isosceles. So that's why we can conclude that angles at the base are the same. So that's why we have two y's the same, okay? From triangle, we have angle B in that triangle equals to the angle C. So that's how we establish y and y, okay? And from triangle BCD, from the big one, which angle C is a right angle in this case, so we can express, obviously, angle y. In this case, we are going to use tangent because we are given 15. Let's say this side is 15 and the top side is 25, okay, due to the fact this is a rectangle. So that's why angle tangent of angle y is going to be 15 to 25. Okay, or as the same as 3 over 5, it would cancel. So from there, we can express angle y itself, okay? So using 10 minus 1 of the fraction, 15, or 3 over 5, or 15 to 25, okay? So we've got 30.96, so 30.96 degrees. We're not going to round at this stage because we rounded at the final stage when we found angle x itself. Okay, so from the triangle BOC, we can conclude that angle x is going to be equal 180 minus 2y, okay? So this is the way. And so we multiply by 2. So let's multiply by 2. I've got 61.92 and subtract from 180. So I've got 118.07 degrees. If you round up to the nearest whole, it's going to be 118 degrees, okay? That's an obtuse angle. Okay, so way 2. So using the way 2, we can actually consider the half of the triangle. So let's put this line from there. So in this case, okay, I'll show it this way. So if I put perpendicular, but I put it down, yes. So obviously I will have angle x over 2 here. So this angle is going to be x over 2. All right, so angle x over 2, because again we have isosceles triangle AOD, we put the height, right? And it's also middle bisector, so that means those bottom sides are the same. So if we consider triangle AO, let's say L, so using triangle AOL, it's definitely a right angle, as we notice that OL is the height for that. So we can express x over 2 immediately because we know that that side is going to be 25 over 2, which is 12.5. Okay, and we know also that side because it's 15 over 2. So remember, that splitting point for the diagonals means that if you put a line, it splits rectangle on 2 equal rectangles in this case. So that's why we will use this fact and say that that side OL is simply half of 15. So it's going to be 7.5. Okay, we have two sides and an angle. So we have opposite side right now, which is 12.5 related to the angle x over 2, and 7.5, which is adjacent, okay? Put adjacent side, okay? So that's why we arrange tangent of x over 2, which is simply 12.5 over 7.5. So opposite over adjacent. From there, we can express x over 2, which is simply 10 minus 1 of 12.5 over 7.5, okay? So we use 10 minus 1 of that. And what I've got 59.036. Okay, now I times by 2 simply, okay? Times by 2, and I'll get, of course, the same result, 118. So x from there is 118. As you can see, the same result that you can obtain two different ways. And let's move to the last one, okay? So we have triangle ABC, so that's the triangle. And this triangle, this is a right angle, so angle B is right angle. BL equals LC, so BL and LC, they're both by 6 centimeters, so that's why I can put 6 centimeters as well. And AB side, bottom side, okay. Yeah, so what we're gonna do, we need to find angle X. Okay, so what we can do, I think the best way is to say that if this small angle is gonna be y degrees, So we can find first angle x plus y using the big triangle. So the first case is to consider triangle ABC, which is a right angle. From that triangle, we can express, so that's opposite side BC, right? And AB is going to be adjacent. So that's why we're going to calculate tangent of y plus x. So that's the total angle A. So tangent y plus x is simply opposite to adjacent, which is 12 over 15. And now we're going to calculate 10 minus 1 of 12 over 15 right now. And it will gives us, so y plus x is going to be 10 minus 1 of that fraction is going to be 38, 65, so 66 roughly, okay? But now from the small triangle, let's consider a small triangle as well. So from the triangle that I shaded, BL, so this is triangle BLA, we can express angle y. So tangent of angle y is opposite. So in this case, small 6 is going to be opposite and still 15 adjacent. So that's why it's going to be 6 over 15. And now we're going to calculate 10 minus 1 of 6 over 15, which is, so angle y itself is 21.8. Okay? And how to find angle x? Just block y here and express. So angle x from this aspect, from this expression, is going to be 38.66 minus angle y, which is simply 21.8. Okay, so that's why finally angle x is going to be equal 38.66 minus 21.8. We've got 1686 degrees, or to the nearest whole, it's going to be approximately 17 degrees. Okay, so we accomplished everything there. So I hope you like that, and don't forget to also consider other more complicated problem involving trigonometry, involving trigs ratios. So here's plenty and playlist dedicated to medium and even medium hard level. If you're pretty confident with that, don't forget to visit 3D trigonometry problems. They might be even more complicated, okay? And don't forget to visit A-level Zillions classes, all right, for A-level stuff. Thank you guys. That was Daniel Dallas. Peace.